This is just going to be a quick recording talking through question 12 on chapter 10, looking at how to put a 3 by 3 matrix into a 3 by 3 system equation into a matrix, and then use what we call reduced row form, reduced row echelon form, so to help us solve. So that's kind of the plan. First step, we're going to take the coefficients and make a matrix out of them. So my coefficient will be 1, -2, 3. So I write 1, -2, 3 across the first row. Where the equal sign goes, I like to put a dotted line. You don't have to. That's just something I do. And then the 9 goes here. And so on. -1, 3, 1, and so on. Okay, that's the first step. So like the directions on the question says, my goal is to end up with 1s on the diagonal and 0s below the diagonal. Okay, so the way I'm going to do that is I'm going to work the first column and try to get 0s. And the way I'm going to do that is add this column, or sorry, this row to this row and try to get this to be a 0. So the first question I have to ask myself is, if I add them together the way they are written, will these two added together make 0? Yeah, it does. So I'm going to add it together. I'm going to leave the first row alone. Simply rewrite the first row. And now add these two rows together all the way down and put the sum here on the second row. So 1 plus a -1, -2 plus 3, 3 plus 1, and so on. First step, I'm going to make these, leave this one alone, and let me backtrack. My first step is to make this a 1. If it was like a 7, I would have to divide everything in this row by 7. If it was a 4, I would divide everything in this row by 4. Okay, so that was my first step. It just happened to be done for me. Okay, this is a 1, so I simply rewrite that row. Step 2, I need to add these two equations together, or these two rows together, to try to get this to be a 0. 1 minus 1 is 0, -2 plus 3 is 1, and so on. Now, when I look at this number here, plus 2 does not give me 0. So I'm going to change this first row, or more importantly, this first cell, or this first entry, to something so that when I add this number to this number, I get 0. I'm going to multiply this number by a -2, because a -2 plus 2 gives me 0. But I can't just multiply one number. I have to multiply the entire row, or the entire equation, if we're solving a 3 by 3 like we would normally do without matrices. So I'm multiplying this by -2, multiply this by -2, multiply this by -2, add these together. Put your sum in this row. So -2 plus 2 is 0, -5 plus 4 is a -1, and so on. Okay, next step. I need to make this a 1. It is. Again, if it were a 3, I would divide by 3. If it's a 6, I'd divide by 6. Okay, it's already a 1. Same logic. I want this to be a 0. So I'm going to add these two rows together and see if I get 0. And in this case, I do. So 1 plus a -1, and I put that here is 0. 4 plus a -1, 7 plus a -1. I rewrite this row because it's already a 1. And I add these together, and that goes in this row. Next step, I have a 1 here and 0s. I have a 1 here and 0s. I need a 1 here. It's not. So like I've been talking about, what if this was not a 1? Well, now it isn't. So this is not a 1, so I divide everything in this row by 3. 0 divided by 3, 0. 0 divided by 3, 0. 3 divided by 3 is 1. 6 divided by 3 is 2. Now, I've done what I needed to do. I set out to make 1s on the diagonal, 0s below it. I'm going to go back now and put it into equation form. This is my coefficient of x, this is my coefficient of y, this is my coefficient of z, this is my equal sign, and this is the stuff on the right-hand side of the equal sign. So I have no x's, no y's, I have 1z equals 2. Perfect, I know what z is now. And I have 1y plus 4z, etc. I'm going to take what that z equals, substitute it back into, that's where the phrase back substitution, I'm going to substitute that back into the equation before it for z. Y plus 8 equals 7, subtract 8, y is a negative 1. I now know z, I now know a negative y, substitute the z, the y, and solve. Z is 2, y is a negative 1, and I work it out, do all my algebra skills, x comes out to be 1. I now know x, y, and z, and I can put it in x, y, z ordered pair format. Okay, hope that helps. If not, say something, and I will do another one.